Okay. All right, take a look here. So we have two of these are what we covered on Thursday, right? X squared minus 14x plus 24, and v squared minus v minus 42. Those two problems are what we covered on Thursday. And like I said at the beginning, you're going to find the factors of your last that add to get to the middle. So in our case here, I find the factors of 24 that add to get to negative 14. Can anybody tell me what they are right away? Like without needing a table. Danielle? Very good. Negative 12, negative 2. I always like to write the smaller one first, so I always do negative 12 and then negative 2, then negative 12. But it doesn't matter. Order does not matter in that case. So in this case, I've got x minus 2, x minus 12. There is my answer. Pretty simple. Gio?
Could you write out the table just so I can see that?
Here's what I mean. You could write it out as negative 1 times 24, negative 2 times 12, negative 3 times negative 8, negative 4 times negative 6. And then you look at what do they all add together to get. Like this adds together to get negative 14, which is what we want. This adds together to get negative 25. No good. This adds together to get a negative 11. No good. This adds together to get negative 10. No good. Does that make sense? Tommy?
Can you put negative 12 first?
Yeah, that's fine. Again, order doesn't matter now. But you know what you can't do? Mix the signs up. Yeah, that is not okay. Like, I know these are both negative, but if one was negative, one was positive, you have to keep the negative one negative and the positive one positive. They can change order, but they just can't be the opposites. And I'll show you what I mean here in this one, because this one is going to require different signs. Okay, what are the factors of negative 42 that add to get to negative 1?
Negative 7 and positive 6.
Good. Negative 7, positive 6. So in this case, we want to say v minus 7, v plus 6. Again, order doesn't matter. V plus 6, then v minus 7, that's fine. But you know what you can't do? Say v minus 6, v plus 7. That's not okay. Because that would come out to be a positive 1 instead of a negative 1. We don't want that to happen. Questions about that? Okay, let's take a look at our third one here. Now, you will need factoring by grouping today. Okay? You will need factoring by grouping today. So please pay attention. If you did not know how to do factoring by grouping, you will need it today. All right, let's take a look. Remember, in any 4-term polynomial, you underline first 2 and last 2 terms, and then you factor out a GCF. What's my GCF out of my first 2 terms?
7.
1 x to the second.
X to the second. Yeah, or 1x to the second is fine. Yeah, but I'm going to say x to the second because there's no GCF with the numbers, like 1 and 7. There's no GCF with that, other than 1, obviously. And then x to the third and x to the second. Smaller power on x is x to the second. So I remove x to the second, and that becomes an x, and then a plus 7. My second set of terms, I've got a negative 3x minus 21. What's my GCF there? Negative 3. Negative 3. Why the negative? Because I lead with a negative in my second 2 terms. So the GCF is a negative 3, or a minus 3 as we bring it down. We divide out the negative 3, and this becomes negative 3 divided by negative 3 is a positive 1x. Negative 21 divided by negative 3 is a positive 7. Then I look at my 2 big chunks that I had again and said, okay, what's my common binomial? X plus 7. So that comes out. And in my parentheses, I write everything that's left over. The x squared, and then the minus 3. And those are my 2 binomials that I use. That is factoring by grouping. And again, you will need factoring by grouping today with what we're doing. All right. Let me answer some questions about the homework. What do we want to go over? Yes, Ron. Number 7. Okay, it looks like I've got v squared minus 5v plus 4. All right, so I'm going to find the factors of 4 that add to get to negative 5. Well, in this case, since I want a negative number, I know both of my factors have to be negative. So in this case, negative 1 times negative 4, or negative 2 times negative 2. So the only one that works, that one. V minus 1, V minus 4. Make sense? What doesn't make sense about that?
Oh, wait, never mind.
Yeah. This is a tricky one where you have a positive number on the end and the middle term is negative. That means both of my factors have to be negative. Not one, but both. What other questions do we have on the homework that we want to go over? Yeah, go ahead.
Number 19.
Yeah? You just want me to go through it?
Yeah.
Okay, so I want to find the factors of negative 20 that add to get to negative 1, right? So if I really wanted to list out all my factors, okay, negative 1 times 20, negative 2 times 10. Does 3 divide 20? No. But 4 does. And at that point, we would start wrapping back around again. So what are my sums? Well, this is 19. That doesn't work. This is 8. That doesn't work. This is 1. But do I want 1? I want negative 1. So that doesn't work. So the only thing that I need to do is make the 5 negative, not the 4, because that's negative 1. So I want x minus 5, x plus 4.
And then last one.
That's okay.
14.
14. All right, factors of negative 18 that add to get to negative 7. All right, so my factors are negative 18. Negative 1 times 18, negative 2 times 9. Bingo, there it is. Negative 2 times 9. Negative 2 plus 9 is 7. So x or z, whatever. Z minus 2, z plus 9. What is negative 2 plus 9?
Oh, okay.
Add, multiply to get to our last, add together to get to our middle. All right, let me hand out the guided notes for you guys today. As soon as you get the guided notes, I want you to foil one of the top 2 problems. There are 2 of them there. You can pick one of them, and I want you to foil it. Make sure the green keys get back into the binders. You can always tell when Mr. D-Lap makes my copies for me. He does his copies in color. In the binder sheet. All right, let's take a look here. Again, you should be foiling. I'm sorry, I got to give you a minute or 2. Foil either one of the top 2 problems. I really don't care. I'm going to do both of them on the board. So you can pick. All right, let's take a look here. Now, when I foil these, I'm going to foil both of them. We got to do first, outer, inner, last, right? First, outer, inner, last. 2x times x, 2x squared. 2x times 4, 8x. 3 times x, 3x. 3 times 4, 12. Combine like terms in the middle, and I get 2x squared plus 11x plus 12. Let's take a look at the next one. 3x times x is a 3x squared. 3x times negative 1 is a negative 3x. Negative 7 times x is a negative 7x. Negative 7 times 1 is a positive 7. Combine like terms. 3x squared minus 10x plus 7. Now, why am I having you doing this again? I had you do this the last time that we had notes. We did this on Thursday, where we FOIL. Why? Because remember that factoring is the same as unmultiplying. Kind of like division, right? I'm reverse multiplying. It's kind of like division. But that's what factoring really is. So there is some connection there. Now, maybe there's that same connection that we had for our ones in the homework. Like all the ones in the homework, we were looking at the last number and seeing how it related to the middle. Does that work again? Let's take a look. Factors of 12 that add to get to 11? Are there factors of 12 that add to get to 11? No. No, there are not. There are not. I bet some people are saying, well, yeah, negative 1 times 12. Negative 1 times 12 is negative 12, not positive 12. So no, there are no factors that add to get to, or that multiply to get to 12 and add to get to 11.
So then what it be?
No, because we've seen that it does have factors, doesn't it? So there's got to be some other way. Here's the moral of the story here for you guys. I cannot just do the rule, factors of your last that add to get to the middle. I can't do that. You're going to find that I classify these trinomials into 2 ways. I call them hard type trinomials or easy type trinomials. The ones that you guys learned on Thursday, those were the easy type. These are the hard type. Now, what distinguishes them? What's different about the setup of the problem? Well, let's look at every problem on the homework. Everybody look up at the board. Every single problem in the homework, was there ever a number out in front of the trinomial? Never. That's what distinguishes an easy type from a hard type. An easy type problem has no coefficient out front. That's when you can just straight up take the factors of your last that add to get to the middle. Done. Put it into 2 binomials. When we start putting a number out front, it takes a lot more work. Several more steps. Okay, several more steps. So what is the connection there? Well, what we have to do is take a look at, because we're foiling these things, because we're kind of undoing that part, what I really have to take a look at are the products of A and C. I have to look at numbers that multiply not to get to just C, but I have to factor in A. Now, you're going to find that, or maybe you wouldn't find, I don't know. You should know that I teach this a little different from other math teachers. I know Mr. Delap teaches it the same way, but I know other math teachers don't teach the method that I teach. And this is going to be nice because if you photomath these problems, they look very different from what I teach. So I will know if you photomath the problems because they look a little different. I use a different method to get to our final answer. I will not allow you to use the photomath method, whatever that is. Okay? You know what that method is? It's called guess and check. I don't love guess and check. I don't like doing guess and check. Why? Because I don't like guessing at the answer to a problem. I like knowing the answer to a problem. So my method has 2 names for it. It's either called the rewrite method, that's what I learned it as, or a fancy way to call it is the master product method. So everybody follow along with the steps that you're going to see here. Now, I'm going to show you an example, and then the steps are outlined in example number 2. Okay, let's take a look here. I've got 2x squared plus 17x plus 21. I want to find the factors of not just 21, but I actually have to find the factors of 2 and 21. I have to factor in my first term because when I'm foiling, I always have to multiply by that first term. So what is 2 times 21? 42. And that's what I find the factors of. I have to find the factors of not 21, but 42. Of 42 that add to get to our middle number of 17. All right, I don't know about you guys, but I don't know the factors of 42 off the top of my head. So I'm going to go here and I'm going to list them all out. 1 times 42. Does that work? No, that would be 43 in the middle, and I don't have a 43 in the middle. I have 17. 2 times 21. Does that work? Nope. Does 3 divide 42? Let's check. 42 divided by 3 is 14. Not 12. 42 divided by 3 is 14. 3 times 14. Does that work? Yes. Now here's the deal. You cannot go straight to your answer. This is what makes the hard type part, is that you cannot go straight to your answer. That's what made the easy type easy. After finding that, we were done. We are not done. We're just getting started. You find the factors of your A times C that add to get to our middle term. This is where my factor by rewrite method gets its name. What I'm going to do here is just copy down my first term and last term, and then I'm going to rewrite my middle term using those two factors. I'm going to rewrite my middle term using those two factors. 3x and 14x. It would help if you wrote things down, Gio.
Just gaze it over what just happened.
Well, the first step is writing it down.
I got the.
No, stop talking, write it down. So 3x plus 14x, I split up 17x into 3x and 14x. I remove the 17x. I rewrite it into 3x and 14x. Oh, I forgot to put my plus 21 up there. Sorry, forgot to put a plus sign in there. Okay, what do you do with a 4-term polynomial? I group. And this is where it comes into play. I want to group my first 2 terms and I group my last 2 terms. What's my GCF of my first 2 terms?
X.
Just x. So we divide it out, leaving a 2x plus 3. What's the GCF of my second 2 terms?
X. 7.
7. 14 and 21. 7. A positive 7. So that makes 2x plus 3. And now look at that. That's why we spent so long factoring by grouping. This is why I stressed factoring by grouping to you guys. Guys, if you don't know factoring by grouping, good luck on tonight's homework. Group the first 2 and last 2 terms. I'm sorry, group the 2 chunks again. What's my common binomial? The 2x plus 3. What's my leftovers? The x plus 7. And those are my answers. Again, it could be in either order. The x plus 7, then the 2x plus 3. Could I FOIL that back again and get my answer? Yeah.
But how do you know that it's first plus 3x, x, and then plus 14x?
Great question. How did I know whether to put the 3x or the 14x first? You'll get the same answer either way. If you put the plus 14x, let me show you. So 2x squared plus 14x plus 3x plus 21, and then I group it. Watch what happens. If I pull out the 2x, that leaves me with an x plus 7. I pull out the 3, that leaves me with an x plus 7. I get 2x plus 3, x plus 7. You see how that works? So it actually doesn't matter the order in which you put them in, which is kind of nice. Okay, can we try that again? From here on, just repetition. Repetition, repetition. You've learned everything that we're going to learn today. Now it's just repetition. So let me outline each step for you because some of you guys like it stepped out like this. So step 1, multiply A times C. What does that mean? In this case, A is 3, C is negative 8. So 3 times negative 8, negative 24. So step 1, multiply first and last. Step 2, find 2 numbers that multiply together to equal A times C, in this case negative 24, and add together to equal B, which is negative 2. Okay, can anybody recognize those without making the list? Danielle?
-6 and 4.
-6, +4. Very good. -6, +4. Step 3, replace B with those two numbers. Copied on our first term and last term. Those don't change. The middle term gets rewritten. -6x plus 4x. And again, that doesn't matter whether we put the plus 4x then the -6x. You're going to get the same answer either way. It just may look a little different along the way. Group the first two and last two terms. I pull out the 3x, which is our GCF of my first two terms, leaving us with an x and then a -2. My GCF of my second two terms is a 4, a +4, leaving us with an x and a -2. My common binomial is the x minus 2. My leftovers are the 3x plus 4. Just more steps. Again, you know all the pieces and parts. You know every piece to this. But what we're doing now is kind of putting a bunch of them together. Honestly, like from here down is factoring by grouping. And we've done that. We've been doing that since last week. The only issue is getting it set up to factor by grouping correctly. And how do we do that? First times last that add to get to the middle. So it's kind of like taking what we did on Thursday, combining it with factoring by grouping. Let's do another one. Flip it over on the back, please. Also, as we go along, you're going to find that because I have to multiply A times C, my numbers are going to get bigger, quicker. Like 3 times 16, that's 48. I don't know my factors of 48 that well. So you might have to have your calculator with you there to get those factors and pick them out quicker. Some of you are going to be fine with it. Some of you guys are good at that mental math stuff. Okay, like for me here, I'm sitting here saying, well, if I got a positive 48 and I'm looking to add together to get a negative 16, both of my factors must be negative, right? This is one of those problems where I got a plus on the end and a minus in the front. That means both of my factors must be negative. So I'm going to go to my calculator and say, oh, well, 1 times 48 is not going to do it. That's 49. 2 times 24, that's not going to do it because that's 26. What about 3? Does 48 divide by 3? Yeah, but is 16 plus 3 going to do it? No.
Could it be like -8 times -8 and just +8?
That's 64.
Oh, I thought 8 times. Never mind. -4, -12.
Yeah. If I divide 48 by 4, I get 12. -4, -12. And now we rewrite our middle term. First term stays the same. I rewrite our middle term into the -4 and -12. Last term stays the same. I factor by grouping. I pull out an x, leaving a 3x minus 4. My GCF out of my second two terms is a -4. Oh, I forgot to write my x there. Okay, you guys get it. And then when I divide, I get a +3 and a -4. So now I factor it down. My common binomial is my 3x minus 4. My leftovers are my x minus 4. See, there is a method out there called guess and check. That method requires you to look at your factors of your first term and your factors of your last term separately. I do that together. They would say do it separately. and then guess at what you think the binomials would be. And then FOIL. If you get it right, awesome. If you get it wrong, try a different combination. If you get it wrong, try a different combination until you get it right.
Takes forever.
That could take, unless you're lucky, you spike it on the first try, then that's good. Good job. But again, I don't like guessing at the answer. I like knowing the answer. All right, let's take a look at this next one. 4. I've got 3x squared plus 7x minus 6. Again, you're not looking at the factors of negative 6. You're looking at the factors of what? Sid?
Would it be negative 18?
Yep, it would be negative 18. Factors of negative 18, 3 and negative 6. Sid, what are they?
I believe it's negative 2, negative 9.
You're close. Negative 2, positive 9. If it was negative 2, negative 9, that would come out to be a positive 18, not a negative 18.
Oh, yeah.
So negative 2, positive 9. And again, how do we get those? We're just running the numbers there quickly in our heads. What are the two factors of 18 that allowed to get negative 18 that allowed to get to positive 7? Just trying some. All right, now I keep our first term the same. We say a minus 2x and a plus 9x, and then a minus 6. The middle term gets broken apart. And then we factor by grouping because it's a 4-term polynomial. So we say our x comes out, leaving us a 3x minus 2, and then a 3 comes out, leaving a 3x minus 2. Our common binomial is our 3x minus 2, and our leftovers are the x plus 3's. Gio?
How'd you get like x? Like use like when you're like dividing with the numbers?
Yeah, you're looking at the GCF. You're looking at the GCF of these two terms. So what's common about these two terms? Well, nothing in the numbers, but they both have an x. That's why my x came out.
What if only like one had an x and the other one didn't?
Then it wouldn't. The x wouldn't be a GCF. Like this one here. This has an x. This does not. That's why there was no x in my GCF outside. Just the number in common was my GCF. Let's keep going. I'd like to do 5 and 6 before we finish today. 5 and 6 are very similar problems. The only difference is the signs and the number on the inside. Both of them require the factors of 20. Number 5 requires the factors of positive 20 that add together to get negative 9. What are they? Factors of 20 that add to get to negative 9.
Negative 5 times negative 4.
Good. Negative 5, negative 4. Now, it does not matter the order in which you put your two factors in. Like when I go down here, I could put minus 4x minus 5x or minus 5x minus 4x. Did I say them in the same order? I don't know. But it doesn't matter. I could change the order and it's not going to change the outcome. I underline first two terms and last two terms and I factor by grouping. It's another one of those ones where just an x is in common here. Question?
Are we ever going to have word problems for this?
Yes, but you'll see why like in chapter 8. Again, we're focused on the how, not the why for right now. Factors of my negative 4x plus 10, my GCF is a negative 2. Yeah, a negative. Right, oh, I forgot to put that underneath, whatever. A negative 2, right? Factors is a negative 2. Negative 4 and positive 10 is a negative 2. So this is a positive 2x minus 5. Yes, it.
I set it up by 2x squared minus 4x and
Then minus 5x?
No, negative 5 minus 10. And
Yeah.
I got x times, and then parentheses, whatever, 2x minus 4, and then I got 5 times x minus 2.
Ooh, then you made a mistake somewhere. Because that is not right. If you do the other order, like that should be my answer. But if you do the other order, so you did 2x squared minus 4x minus 5x plus 10, yes? Okay, then my GCF should have been a 2x, leaving an x minus 2. And then a negative 5, leaving an x minus 2.
I got the last one, but I got the
Yeah, I think you forgot to divide this by 2.
Yeah, I think so.
Yeah. All right, let's take a look at number 6. Again, I need the factors of 20. But in this case, negative 20. Factors of negative 20 that add to get to what? 1.
Would it be? Oh yeah, 5 negative 4.
Good. Yeah. Negative 4 times positive 5. When I have one of each, I always put the negative factor first. Okay? Listen to me on that. When I have one of each, a negative and a positive, I always put the negative factor first. Do you want to know why? Because if I put it second, wouldn't I have to lead with a negative? And you guys tend to make mistakes when you have to factor out a negative. So if I put the negative in the front, that's not going to happen here. So when you have a choice, put the negative factor first. Pull out the 2x, leaving an x minus 2. Pull out the 5, leaving an x minus 2. So we have an x minus 2, whatever, and then a 2x plus 5. Remember that you could check every single one of these answers by foiling them back together if you wanted to, just like we did in the very beginning of our guided notes today. Okay, your homework tonight, page 401, numbers 7 through 12. Again, I'm going to sound like a broken record. I cannot say it enough. Do your homework. If you're not doing your homework, it's going to be an issue. Not just for your grade, not just for your homework, but for your quiz and test grade.
When is everyone going
Next Tuesday.
So we have a while.
What's that?
So we have a while.
Yeah. It's going to be over 7.5, 7.6, and 7.7, which we'll do 2 days on 7.6. 7.7, I believe, is on Thursdays. Then we'll review Friday, Monday, quiz Tuesday.
All right.
Happy Tuesday, everybody. Happy Tuesday.
We should celebrate